So there are 50 questions here, roughly. And the integrating part is not the hard part. It's hard, but it's doable. It should be quite easy once you get the question. The hard part is none of these questions tell you which method to use. And as you know, there's like 4 or 5 different methods just for integration.
Yeah.
Integration by substitution, integration by parts, integration by partial fractions, and integration by reverse chain rule. So let's go through a few of them and just say what method to use. So
Okay.
if you saw question 1, what would you do?
You can use reverse chain rule, right?
Yep. And what else could you use?
Substitution.
Good. And what do you feel more confident doing?
I like substitution.
Cool. So what would you use as your u?
4x plus 5.
Cool. Can you try that? So for this one, you make u equals 4x plus 5. So du by dx is 4. So this becomes u to the half times by a quarter, which can go outside, du, which equals a quarter u to the power 3/2 times 2/3 plus c, which equals 2/12, so 1/6, 4x plus 5 to the power 3/2 plus c. You can also use reverse chain rule, but it's up to you.
Yeah.
Question 2, what method would you use for that?
There was part, it's not parts.
So whenever you see a fraction, it's logs.
Oh.
So
What's that method called?
There's no method. It's just a
Oh.
form. It's just a thing to know.
Okay.
So 1/x always becomes
ln x.
Yeah. So 1/4x plus 5 becomes
Ln 4x plus 5.
1/4 and then ln 4x plus 5.
Oh.
Okay.
Yeah.
The 1/4 is because of the reverse chain, or just memorize it. It's always 1/4.
Okay.
It's like if sine 2x, it doesn't become cos 2x. Minus cos 2x. It becomes minus 1/2 cos 2x.
Yeah.
Question 3.
That's like the same as the first one.
Question 3 is year 12. Okay.
Yeah.
So 1 minus 1/x, 1 minus 1/x. Expand the brackets.
Oh.
If it's just a square, just expand the bracket. The first one is a power of a half. You can't expand that. But if it's just a power of squared, you can just expand it, right?
Yeah.
So 1 minus 1/x minus 1/x, so 2/x, which is, yep, that's fine. And then plus 1/x squared. So that's integrating 1 minus integrating 2, 1/x. I take the 2 outside, and then integrating x to the power minus 2. That's year 12, that's year 12, and that's ln x.
Okay. So wait, so what does that one become?
2 ln x. Yeah?
Yeah.
Okay, so far, question 1, substitution or reverse chain rule. Question 2, because it's 1/, it's ln.
Yeah.
Question 3, because it's just squared, expand at year 12.
Okay.
Okay, question 4 gets hard, so have a think about that one. For question 4, there are 2 methods. Both of them will come in handy depending on the question. For this one, substitution is easier, so I'll just do that. But you should know both methods. So question 4, if I'm integrating cos x sine x, I would just make u equal to sine x. Because I know that when I differentiate sine x, I get cos x. So therefore dx is 1/cos x du. If I do that, everything cancels out so nicely. So I get cos x.
But how do you know that you were sine x?
Yeah, that's just practice. No, it doesn't actually matter. You can also make u cos x. It would be the same thing.
Oh, okay.
So both would be fine and something would cancel. So I get u 1/cos x du. They cancel. So I'm just integrating u, which makes u squared over 2 plus c, which is a half sine squared x plus c. Okay. If I did u as cos x, it would become minus sine x. So it would be -1 over sine x. So the sine x would cancel as well. It would be the same thing. The second method is this trig identity. I would not do it because it's hard to even tell, but you should try and remember it for the hard ones. So sine 2x equals, do you know what that equals?
Is it 2 sine A cos x? 2 sine x cos x.
Perfect, 2 sine x cos x. If we know that sine 2x is 2 sine x cos x, then sine x cos x is equal to,
Sine x.
if 2 sine x cos x is sine 2x, what would just 1 sine x cos x be?
It's half sine 2x.
Yeah, half sine 2x. This question says integrate sine x cos x, right?
Yeah.
So we could just integrate a
Oh.
half sine 2x.
Oh, yeah.
I'll move the integration sign here, and then that's easy, right? Sine turns into minus cos, okay?
Minus 2 cos 2x.
Minus a half cos 2x.
Oh,
Just remember it's divide and integration
yeah.
plus c. So that also works. So minus a quarter cos 2x plus c. Now, both answers were different, but you can use a trig identity to make them the same. But it's your choice. But sometimes it depends on the question. The question might say use a trig identity
Oh,
because it might be with double angles or trig and as well as integration together.
yeah. Cool.
And we're going to need this later more than for this question.
Cool.
So whenever it's cos x sine x, whenever it's two trig, so even for question 9 and for question 12 and stuff like that, we're going to use substitution in my preference.
Okay.
So question 1, reverse chain rule, substitution. Question 2, logs. Question 3, year 12. Question 4, substitution. Question 5, formula book. Okay.
We need to do the double angle for tan. No.
No, you can just use the formula book, luckily.
Oh,
But that's what another thing. So now all 5 questions have been different methods.
yeah.
So 5 is even, I would even count formula book as a method. Yeah.
Oh, yeah.
So in the formula book, can you get it open? Wait, have you got one? Okay, so for question 5, the formula book says integrating tan kx becomes 1 over k then sec kx. So in that case, what would we get for integrating tan 3x?
1 over 3 ln sec 3x.
Yeah, plus c.
Yeah.
Good. So that's just a lesson to always check the formula book if you're not sure, or just to remember what is in the formula book. Okay.
Cool. Yeah.
Question 6.
Isn't this formula book as well?
X sine 3x. No, probably not.
Oh, this is timesing as well.
So
So
what
it's
is it?
parts.
Parts. Okay. Can you do it? But yeah, because it's two things times together, which are both different, then you would do parts.
Okay.
The first thing I would do is say that X, I would literally just write a capital A because it's algebra and a capital T because it's trig. And then remember late. So A is before T, so then that should be my U. And then that should be my dV by dx. And then you can just carry on straight into the formula. So I just worked out UV minus V du by dx by integrating sine 3x. Then we just tidy up. That's important. Every time you do a maths line, especially in a hard question, tidy up. So x times that becomes, just rewrite the order of it. So -1 over 3, x cos 3x. Minus minus is plus. And a third would rather be outside the integration sign, because otherwise you'll start getting confused. Okay.
Yeah.
And then that becomes I change it to a bracket and I integrate it. So that's a third sine 3x.
Yeah.
And then the final step, plus c, and then that becomes 1/9, which I'm not going to do now, and then you're done.
Okay.
Good. Question 7.
This is substitution.
What would you substitute?
I think it's x minus half. Or is it x
No,
half?
7 is year 12.
Oh,
Okay. Why is
Yeah.
it year 12?
you just bring the x to the top.
And then what
So
would you
could
do?
I not do substitution?
I wouldn't even bother trying.
Oh.
Just do year 12.
And then
Sometimes it's
expand
fine,
it.
but in this, if it's year 12, just do year 12. It's easier.
And then expand it and then integrate.
Yep. Help me expand it. What would I get?
It's x to the power of minus one half. And then x to the power of half.
Good. And then that's easy.
Yeah.
So I'm not going to go over that. Good. Question 8.
That's substitution
Yep. Of what?
of u equals 1 plus x.
Well done. Good. Question 9.
And that's parts.
Because it's two things times together, I would suggest parts. But when I did question 4, I said if it's sin x and cos x, or just in general two trig
Or
things,
the identities.
I would rather just use substitution of one of them. Like it's always like, wait. So you know how you said 8? Wait, did you say substitution for 8?
Yeah.
Okay, so let's go back to question 8.
Okay.
It's x 1 plus x to the power of minus 1, right?
Yeah.
Okay. Question 9 is sin x cos x to the power 4. A general good rule is whatever has a power, make that u. So hopefully they'll tell you, but if they don't, that's your u, 1 plus x. In this case, that's under a power, so that's my u.
Oh.
Also, in
okay.
question 4, it was cos x, sin x. Both of them were the power 1, so any of them are fine. So I just made that u.
Oh.
And also,
Okay.
when you differentiate sin x or cos x, it becomes the other thing.
Yeah.
So it will cancel out beautifully. Okay,
Yeah.
cool. Can you try number 9? So if u is cos x, the same thing happens as in question 4. So du by dx is minus sin x. So dx is equal to minus 1 over sin x du. So this becomes sin x u to the power 4 minus 1 over sin x. So those cancel out and we get integrating minus u to the power 4, which is just u to the power 5 divided by 5. And then put your u back in. Question 8 is actually a little bit similar, but also a bit harder because you're going to have to, the u's won't cancel, the stuff won't cancel out, so you have to make x a subject as well.
Oh, okay.
Question 10 is also tapped.
Why? 3 lambda
Why?
x.
I messed up earlier on it, but how do you think we have to do 10?
Which method?
Yeah.
It was the log method that you said.
So if it's 1 over x, it becomes ln x.
Yeah.
But this is ln x.
It's not 3 ln x.
As in, when it's 1 over x, it integrates to become ln x. Ln x doesn't have an integration. Ln x differentiates to 1 over x.
Oh.
That's why it's confusing. Because you think, oh, just 1 over x, but no. So whenever it's ln x, it's a rule. You have to use integration by parts.
Oh.
It's the only way to do it.
Okay.
So if you're integrating 3 ln x, so
the 3
log
separate
is
then.
always, so that's L, and then that's nothing, okay? So that is U, and then that is dV by dx.
Okay.
So,
V is 3.
yeah, so U times V, so U is ln x, V is 3x, if I integrate 3,
Yeah.
minus 3x again, du by dx. So ln x differentiates to make what?
It's different. 1 over x.
And then the x is cancelled. So it's 3x ln x minus integrating 3, which is 3x ln x minus 3x plus c.
Oh.
But it's another new method. We've done about 15 questions and we've got 10 different methods.
Yeah.
So the ln x, you have to use parts, where the ln is the u. It's the only way to integrate ln x.
Okay.
Okay.
Yeah.
Cool. Cool. Question 11, what would we do? Another new method?
This is this partial fraction?
Yeah, it's another new method. Every single
Yeah.
question's been a different method. So
Yeah.
number 11 is partial fraction. So why is it partial fraction? Because, well, it's just, it just makes, so that would become a over x plus b over x minus 1. So we have to figure out what that is. So first, let's just do that separately. In a real exam, it'll either be part A, turn it to partial fractions, part B, hence integrate, or it could just be a 4-5 marker.
Okay.
So x plus 2 over x minus 1 equals a over x plus b over x minus 1.
Yep.
Which means x plus 2 equals, you have to set up the partial fraction thing to solve for a and b.
First you have to, so it's a times x minus 1.
Yep.
And b times x.
Good. Over, both of them over x minus 1, but they cancel out. So we don't need the denominator.
Yep.
Let x equal 1. So 3 equals 0 plus b. So b equals 3. Let x equals 0. So 2 equals a times minus 1 plus 0. So a equals minus 2.
Yeah.
Then that means we're just integrating minus 2 over x plus 3 over x minus 1. Can you try that? It's way easier than you think. And you have to remember every time you do partial fractions, the point is you're going to get logs, remember?
Oh.
So it's minus 2, integrate 1 over x, plus 3, integrate 1 over x minus 1.
Yeah.
So what does that become?
Minus 2 ln x.
Yep.
Plus 3 ln x minus 1.
That's how easy it is. Plus c.
Oh.
Don't forget plus c. But yeah,
No.
if you don't mess up and do to power minus 1, partial fractions or any fractions always become log.
So this would have been wrong straight away. There's no way to.
Well, it's still log, but you're just writing it in a way that will make you get confused because you're going to try and raise the power up.
Yeah.
Cool. Question 12.
What is that? That must be substitution.
Probably. So I've written it like that. So what would your u be?
U will be 1 plus tan x.
It could maybe be sec, but most likely it's 1 plus tan x because it's the thing I was saying before. Whenever you have something to a power, if it's 2 things times, you can use parts, but it's 2 trig things. So just use one of them, and then most likely you have to look for a trig identity. This question will be substitution of u equals 1 plus tan x and the formula book and trig.
Okay.
What's du by dx? 1 just disappears, yeah?
Yeah.
And then what about the tan x from the formula book? It's fine, use this. What does tan x differentiate to?
Sec squared x.
Yep, so that's just straight from the formula book if you're confused. So tan x becomes sec squared x because of the formula book. Cool. So that means dx by du is...
Are you gonna do it like that?
Wait, what?
Are you not gonna do dx equals?
Yeah, I'm gonna do that now.
Oh.
I could make that cos squared x, but I don't need to because remember that thing about in an easy substitution question, something should always cancel out. So it's sec squared x, u to the power minus 3, 1 over sec squared x, du. Cancel, integrate that, done. Easy.
Oh,
Okay, but again, you won't know what to do. So because it's something to a power, it's most likely substitution. If not, you can experiment with the other methods. But
okay.
the first thing you should think is probably substitution. But
Do you see here? Did you have to bring that to the top?
it's easier to spot that there's a power, but you don't have
Oh.
to. You're gonna get it wrong. You're gonna have to try 2 methods or 3 methods. Let's just go a bit random, okay? So we just did 12.
Yeah.
There's some really obvious ones, okay?
Yeah.
Like what method is 16?
Parts.
Parts. What method is 17?
Substitution.
Probably
Or
not.
is it year 12?
Probably not.
Oh, logarithm. Wait, isn't it?
Wait, actually, let me not rush it. So
Oh.
16 is like an easy one, so I'll skip that. But let's just keep going in order because there's some hard ones there. 13 is hard. Since I did talk about it, 17 is 1 over x plus 2, 1 over x 1 over x plus 2, x minus 2.
Oh,
Partial
gosh.
fractions and then logs.
Okay.
So yeah, 16, 17 are cool. What would 18 be?
18. That's not partial. Partial. Is that? That's substitution.
Yep.
Most of them are substitution.
Mm, yeah, well, they're a bit random, but yeah, a lot of them are substitution.
Yeah.
Okay, so 16, 17, 18 is done. Just we know the methods. That was a good bit of a 19, what would that be?
That's also substitution.
It's squared. What do you do if it's squared?
Oh, you just expand it and
Year
year 12.
12. Exactly, good. So 16, 17, 18 is cool. 16 is parts. 17 is partial fractions.
Yeah.
But you can maybe try and use reversion. I'm not sure if it will work. 18 is substitution. 19 is expand year 12. 20 is probably, yeah, 20 has to be partial fractions,
How?
like that.
Oh,
So it's 1 over 2 minus 3x squared, which is 1 over 2 minus 3x, 2 minus 3x. So you make that into partial fractions.
yeah, that one.
Or you can also try reverse chain rule, but I'm not that confident with it.
Wow.
21 is easy, but hard to tell the method. Do you know? 21
Mhm. No, I would have
is
said,
easy. 1 over 4 minus 5x.
oh, that's logarithms.
Yep, so what would it be?
It'll be 1 over 4.
1 over 5.
Huh?
1 over 5, and then
So then what happens to the 1 over 4?
no, the 4's it's the thing in front of the x, not the thing in front of the 4. Just
Oh,
and then what?
um,
Then 4 minus 5x.
oh, wait,
Yep.
but I know how you got 1 over minus 5, but
So write it like this. 1 over minus 5x plus 4. It's the thing in front of the x.
oh,
The
okay,
4 doesn't matter.
okay,
Yeah, so it's minus 1 over 5, and then that's the outside, and then integrate that is just ln minus 5x plus 4.
okay,
But obviously, if you just look at a power minus 1, it's going to confuse you. But if you look at a fraction, you'll remember partial, like the fractions thing is logs.
yeah,
But all these things you have to have in your head, which is what makes integration the hardest topic. Okay, I started rushing. Let's go back slowly because I wanted a bit of a break. But 13, 14, 13, 14, 15 are hard. So let's go back to that. Okay.
cool. Yeah, 13 looks hard.
So 13 is a bit of a mad one.
It can't even be parts, can it?
Is trig identities.
Oh,
So this one is, wait, 13 is really weird, but there might be a quicker way to do it, but let's try this. Whenever I see sine squared x, or whenever I see cos squared x. So if I see something like sine x cos x, I would just use substitution, but
Yeah.
you can use the 2 sine x cos x double angle. Okay.
Yeah.
But whenever I see sine squared x, or if I see cos squared x, I have to think of the cos 2x double angle.
Okay.
Okay.
Yeah.
So I know that cos 2x equals 1 minus 2 sine squared x.
Yeah.
Okay. Or cos 4x equals cos 2x plus 2x, which equals cos 2x sine 2x, no, cos 2x plus sine 2x sine 2x. So it should be 1 minus sine squared 2x. If cos 2x is that, then cos 4x should be that.
Yeah.
So we can use that, okay? So if we have to integrate sine squared 2x, let's try and write it in a different way. So let me just rub out everything else. So therefore, 2 sine squared 2x would equal 1 minus cos 4x.
Oh yeah, because of what was up there.
Yeah.
Yeah.
So sine squared 2x would also be a half minus a half cos 4x.
Yeah.
So if I want to integrate that, I can just integrate that instead.
Oh.
And a half becomes a half x, and then that becomes 1/8 sine 4x
Yeah.
plus c.
Okay.
Nobody's ever going to get that first time. Okay, I would never have got that in
Yeah, the
reality.
identity is weird.
But I'll show you again when to use it later when it comes up. But whenever you see sine squared x or cos squared x, you have to use the double angle for cos squared. Sorry, for cos 2x.
Okay.
I'll show you another example.
Yeah.
So that was number 13. So let's try number 50.
Cool.
Wait, what did we say it was for 14?
I think we said substitution.
Yeah, substitution of x minus 2, right?
Yeah.
It's probably a bit of a harder one, but it should work.
So shall I do 14?
Okay. Wait. Leave 14, you can do that after on your own. If you get
Okay.
stuck, just ask me.
Okay,
Because
cool.
I'll give you this later. Let's do 15 because it's going to go over my point again about the trig thing.
Okay, cool.
If we first start by expanding 15, because otherwise we've got no chance of doing it.
Yeah.
So what happens when we expand it?
It's sine squared x
Yep.
plus sine 2 cos x.
So 2 sine x cos x, good.
Yeah.
Plus another 2 sine x cos x.
Yeah. Plus 2 cos squared x.
Good. This is where that thing I was talking about comes in.
Yeah.
So I have two identities which I know. I know that sine 2x becomes 2 sine x cos x. Okay.
Yeah.
I'll use that to my advantage here. So if sine 2x becomes 2 sine x cos x, what is 4 sine x cos x?
It's sine 2 sine 2x.
2 sine 2x. That's what I'm going to write that as later.
Okay.
Cool. Also, I know that cos 2x is equal to 1 minus 2 sine squared 2x, or 2 cos squared, sorry, I just meant x, minus 1. And I have to use that here and here. Okay.
Yeah.
So if I know that, what would 2 cos squared x be?
2 cos squared x is cos 2x.
plus
+1.
plus 1, right?
Yeah.
And for this one, what would 2 sine squared x be?
It's cos 2x minus 1.
So if I just have 1 sine squared x, it's a half that, right?
Yeah.
Okay.
Yeah.
I have to substitute all of these things in. So instead of okay, just ignore the circle. Instead of integrating sine squared x, I'd rather integrate that.
Well,
Instead of integrating sine squared x, what would I rather integrate?
half cos 2x minus half.
Instead of integrating 4 sine x cos x, what would I rather integrate?
Also, 2 sine 2x.
Instead of integrating 2 cos squared x, what would I rather integrate?
Cos 2x plus 1.
Yeah. Now these are all easy to integrate. This would be like 10 marks or something. I don't even think it would. I think they'd violate and make it 5 or 6 marks.
Oh,
But it tells you that if you see this, you have to do
Yeah.
the reverse of the double angle for that. And if you see this or this, you have to do the reverse of those double angles.
so basically you need to change. No.
But change them back to double angles. So
Okay.
always when you see a double angle, you use the formula. But for integration, we want a double angle
Oh,
because those are
okay.
easier to integrate. We don't know how to integrate squared.
Yeah.
So then this is now, where did this come from? This is now easy. So how do you integrate a half cos 2x?
Yes. Minus a quarter sine 2x.
I think it's just a quarter, but it's fine.
Why?
Cos integrates to minus sign. Sorry, cos just integrates to sine.
Is it?
Yep.
Oh. So what does cos differentiate to?
Minus sign.
Oh,
And then what does a half integrate to?
half x.
And then what does 2 sine 2x integrate to?
It's times by half, so it's cos 2x.
Minus cos 2x.
Oh, yeah.
And then what does cos 2x integrate to? Same thing again, so it's just minus a half. No, wait,
Isn't it
plus a
just
half cos 2x.
Yeah.
Then 1 integrates to
Like,
x
is that not
plus
sine?
c. Yep, sorry. Plus x plus c. Done. Collect like terms. So you got a quarter sine 2x and a half sine 2x. So that's 3/4 sine 2x. Minus a half x and 1x becomes plus a half x. And then minus cos 2x plus c. So that was the hardest one.
Yeah.
Okay. So for this question, there's two things multiplied by each other, so it's going to be integration by parts. X squared is algebraic and that's exponential, so that would be my u, and then that would be my dv by dx. When you integrate that, you get a half, no, 1 over a half, so 2 e to the half x, and then you just apply the formula. So we get uv minus integral of v du by dx, which is x squared 2e to the half x minus the integral of v 2e to the half x times u, which is x squared. And we notice that it has not worked. Oh wait, du by dx, my bad, which is 2x. But we have noticed that it doesn't seem to work. So let's tidy it up. That will be the next step. So 2x squared e to the half x. So tidying up literally just means writing it in a better order. And then take the 2 out, minus 2, integrate x e to the half x. And what we have to do there, what do you think? You can't integrate x e to the half x in one go, so what should we do?
Substitution.
Of what?
Oh, chain rule. First chain rule.
Well, actually, we just have to do parts one more time and it will be really easy.
Right, yeah.
But that's where it gets messy. The reason I know that parts will work is because x will cancel to 1 and you won't have another x there. So it actually worked. But otherwise, because sometimes at that point you realize it's wrong and scrap the whole method. But we're confident it's working. We just have to do it one more time to get rid of the x.
Yeah.
And that's quite normal. That can happen. Let's watch. Okay, so we have to do parts again. There's two ways. I can either do an arrow or a margin and just do that separately. That might actually be easier. So integrating x e to the half x is uv minus the integration of v du by dx, which is which is x times, when I integrate that, it's 2e to the half x minus integration of 2e to the half x times 1 when I differentiate x. See, that's working, right? So 2x e to the half x, I've tidied it up as well, minus 2 integrate e to the half x, which is 2x e to the half x minus 2 e to the half x plus c. We don't need to put the plus c because we're going to put it in more stuff. So just 2x e to the half x minus 4 e to the half x. And then we can just write our answer straight away. So 2x squared e to the half x minus 2. Copy the answer. Or I'm just going to times it by 2 straight away. So 4x e to the half x minus 8 e to the half x plus c, using that. I'll just put a note. In mark schemes, it just does it straight away. So mark schemes can be confusing. Just do a margin and do it somewhere else, and then just say that you use that result. You'll get rewarded a lot of marks for it because it's obviously a hard question, but it'll be a good few marks.
Right, yeah, of course.
But just ask for extra paper if you need it, or just space everything out nicely. Because if you treat them as two separate questions, it's not actually that hard. Like that alone is not hard. That is hard, but you've just got that answer.
Yeah.
Okay. Question 17. What method is that?
17 is substitution.
Of
X
what?
squared. What's x squared minus 4 to minus 1?
That can work, or there's a bit of an easier method. Partial fractions. But let's try both.
Oh, yeah.
Which one do you? I'll give you.
I prefer that though.
Yeah, shush, man, it won't work. So if you do that, if you do substitution, nothing will cancel out, but you're free to try it. Sometimes it does work. We have to use partial fractions. So to integrate 1 over x squared minus 4, we have to write it as 1 over x plus 2x minus 2, which is a over x plus 2 plus b over x minus 2. And then we have to work out a and b. So do the thing I said last time where we draw a margin, work out the question, work out that stuff we need, and then come back to it.
Right, yeah.
So we know that a x minus 2 plus b x plus 2 equals 1. 1, right?
Okay. Wait.
So what do? We let x equal 2.
2.
So
Minus 2.
a times 0 plus 4b equals 1. So b equals a quarter, and let x equals minus 2. So a times minus 4 plus 0 equals 1. So a is minus a quarter. So which equals minus 1 over 4 x plus 2 plus 1 over 4 x minus 2 using that.
Mm-hmm. Lin.
So an easier way than expanding is if we do minus 1 over 4. No, remove the constant before the integration sign. See how easy that is. You don't have to integrate the constant, take it outside. So it's minus a quarter ln x plus 2 plus a quarter ln x minus 2. Yeah. What could be a good follow-up question that the exam board could give?
I don't know.
And it
Show
could be
x equals e
rearranging.
to the 4 or
So
something.
you might have to put that up or something and put that up
Yeah,
and
yeah.
use the log rules and stuff like that.
Alright.
Partial fraction is a very underrated topic. It's really easy, but people just think it's easy and then they forget to revise it, and then
Yeah.
it's a big one. Because it can come up with binomial expansion and with integration. Question 18. Let's get through as many as we can. All right, so for this question, I would write it like that. It looks like partial fractions, but you can't turn it into partial fractions because the denominator can't be factorized. So just use u as that and everything should cancel out really nicely. Question 19.
Did I get it right?
What method is question 19? I'll mark that in a second, sorry.
19 is substitution.
Nope.
See, if that was me, I would
So-
expand it.
So from part 1 of the video, which you weren't
What I'll
there
do is
for-
I'll expand it.
Yeah,
and then
so
solve it as
that's
normal
it. Yeah,
integration.
yeah, it's year 12. That's what I wanted to hear. So expand in year 12, easy.
Yeah.
Question 20?
Substitution.
No,
Yes.
no. Well, no. Substitution
My
will
boy's
work.
lagging.
No, substitution will work perfectly, or
Bubbles.
partial fractions,
Question 20.
or reverse chain rule.
Question 20.
Yeah, so it's 1 over,
2 minus 3x.
1 over 2 minus 3x, 2 minus 3x. And you can do partial fractions, or you can use substitution, or you can use reverse chain rule. All three would work.
All right.
Do you want to try? Would you have doubts about any of those methods?
No.
Okay, I think that one's all right, to be honest. If you're stuck.
Actually, reverse chain rule, I'd have that as well.
Should we quickly try it?
Yeah.
Okay.
So it's 2 minus 3x to the minus 2.
So that would equal something, and then 2 minus 3x to the power minus 1.
Yeah.
But we need to work that out. So if we were to differentiate that, we get 2 minus 3x to the power minus 2 times by the inside part, which becomes minus 3.
Yeah.
So this has to be minus a third to make that. It's like the reciprocal of that. It's always the reciprocal of that. No, sorry, it's the reciprocal of that always.
Okay.
Basically, differentiate the inside part, and that's what gets multiplied.
All right.
Yeah, good. And that's obviously way quicker than the other methods, but hardest to remember.
Yeah.
So feel free to use substitution.
All right.
Good. Question 21. Very easy one.
We just go through all of these.
Yeah, but we'll go through very fast.
4 minus 5x. Wait, you just ln.
Write it properly and tell me the exact answer.
It's not just ln 4 minus 5x.
No, it's minus 1 over 5, then 4 minus 5x. The rule for 1 over kx is 1 over k.
Oh, no, I actually do know. Because
The-
if you integrate 5, it doesn't become 1, obviously.
Yeah, exactly.
So you use a fifth.
It's the
really
mix
1,
of reverse chain rule and that stuff, but just remember the rule. It's always 1 over k goes to the front. Good. Question 22, easy one. But you need the formula book.
What? 3,
So this was not an easy one. So I would do it as sine 1 over tan 3x, which is cos 3x over sine 3x, and then do substitution of either sine or cos. Let's just do it as sine 3x. So then du by dx is 3 cos 3x. So dx is 1 over 3 cos 3x du. So that's cos 3x over u times 1 over 3 cos 3x, which is a third 1 over u, which is a third then u plus c, and then put u back in. Next one, question 23. Okay, so in the formula book, you know that wait, it's not. We know that cosec kx differentiates to make minus k cosec kx cot kx. So then in this case, the answer will just be minus 1 over 2 cosec 2x plus c.
Fractions.
Yep, let's just do random ones because the worksheet's dead now. So number 32, partial fractions, like you said. What about number 33?
I would do.
It's partial
You can't do
fractions
partial
again.
fraction. I was about to say that.
It's
Yeah,
partial fractions again, but it's a harder partial
you
fraction.
expand the bracket, don't you?
Yeah.
That's
What
what I was
about number
thinking.
35?
35. Ooh. Oh, this is a weird one. It becomes like you.
Isn't it one of those weird log ones?
That's what I was thinking. Weird lim one. When
But I don't know the
inverts.
rule. Yeah. Can you not do substitution though? Or would it not work? Yeah, you can. What
X plus 4.
What would you substitute as u?
X plus 4.
Yeah, try it.
You could work. 35.
So for number 35, so let's do 35 and 31 because it's similar, and then 25 and 28. So 35, x plus 4 over x minus 4. So u is x minus 4. So du by dx is 1. Dx by du is 1. And also, so we get x plus 4 over u du. Let's make x the subject. So x equals u plus 4. So we get u plus 4 over u, which is u plus 8 over u, which is u over u plus 8 over u, which is integrate 1 plus 8, 1 over u, which is u plus 8 and then u plus c. Yes, I'm sure it's substitution.
That sounds
So
fine.
what's the first step?
U equals x squared plus 1.
Yeah, and then?
You differentiate, so
Cool.
u over dx equals 2x.
Yep. Then dx is equal to 1 over 2x du.
Yeah.
Should we try that? So x plus 1 squared over u times by 1 over 2x. Now, stuff isn't really cancelling out, so what should we do? Okay, so what do we do if it doesn't cancel out?
We are screwed.
You did it before. So make x the subject. So let's make a couple of things. So we can make 2x the subject and see what happens, and we can make x the subject, right? So x squared equals u minus 1.
X equals root u minus 1.
So we have those. So let's try it. It might not work, okay? So we've got square root u minus 1 plus 1 squared over u times 1 over 2 root u minus 1. We can either spend like 2 minutes trying to figure out if it cancels out or not, Not sure. It seems kind of long, okay? Because we got this far, we might as well try. So we have to expand the top bracket
Yeah.
and tidy up the bottom bracket. So we get
So root u minus 1 plus 1
root
squared.
u minus 1 plus 1, root u minus 1 plus 1, expand, right? And then that's going to be over 2u u minus 1. I don't think this will work, but let's try. U minus 1 times u minus 1 is root u minus 1.
u minus 1.
And then plus,
U minus 1.
no, plus root u minus 1 plus root u minus 1. So plus 2 root u minus 1
Bro, what?
plus 1.
Yeah.
Yep, over that whole thing again. Yeah, there's no way we're integrating this. The ones cancel out. Oh, okay. So yeah, we can't do this question because you have to split it into two fractions. It's really weird, so just don't worry about it. Let's skip this question and do 25 and 28 as the last couple questions. So for this question, we have to use integration by parts. So you got algebra and trig. So u is x, dv by dx is cos 5x. So when you get v, it's 1 over 5 cos 5x, and du is just 1. That's how you know it's nice for integration by parts, when u differentiates to 1. That's how you know it's like a nice parts question. So we've got uv minus v du dx. So uv is a fifth x cos 5x minus 1 over 5 cos 5x times 1. So that's really nice. So then you just get, that just becomes 1 over 5 sine 5x again, and then you just put it back in and finish it off.
Yeah.
That was an easy one. Last question, can you do question 28?
Let us assume I is equal to integral of cosine of 2 times the trigonometry identity cosine of 2 times x is equal to 2 times square of cosine of x minus 1. The video appearing in the upper right corner explains the proof of this trigonometry identity. The link of the video has also been given in the description section. I have replaced the cosine of 2 times x in the integral by its value given in the above trigonometry identity. So I is equal to integral of 2 times square of cosine of x minus 1 times sine of x. Straight multiplication gave us I is equal to integral of 2 times square of cosine of x times sine of x minus sine of x.
Actually makes sense so far, right? Because we were actually doing that.
Yeah.
With respect to x. I have applied the linearity property of integrals. So I is equal to integral of 2 times.
Wait, oh, then that's easy to integrate. That just becomes minus cos x. And that we use substitution of u equals cos x.
Yeah.
Differentiate u equals cos x,
Sounds really
then
easy.
the sine x cancel out. So this was a trig identities question. I knew that, but I was stuck. So we used the trig identity, expanded it, and then we have to use substitution for this part. And then
Yeah.
that's easy.
Alright, yeah.
So here u is going to be cos x.
Square of cosine of x times sine of x with respect to x minus integral of sine of x with respect to x. We know the antiderivative of sine of x is minus cosine of x. So I is equal to respect integral of 2 times square sine of substitution method. To solve this integral, let us assume cosine of x is equal to u. Differentiating both the sides of the above equation gives us derivative of cosine of x with respect to x times differential of x is equal to differential of u.